Hello everyone, welcome to Northern Aeronautical. My name is McCoy, and what you just saw was our most recent test of our NE-7 rocket motor. That test was supposed to gain thrust data on the motor, and obviously it didn't go so well. And that's what we're going to be talking about in this video. What happened, what went wrong, and what went right. But before we get into that, let me just catch you up with the NE-7 rocket motor and what it is, so we can get into the more detailed stuff about what went wrong.
Okay, so what we have here is a very basic cutaway graphic of our NE-7 rocket motor. So, how does it work? Well, first let's go over all the parts of it. This orange section here is the casing and nozzle. This gray section is the fuel, and this black piece at the end is the end cap. Okay, so how this motor works is that an igniter is placed right here within the fuel grain core, and the core is just a hole in the fuel to increase surface area. So it's placed in there and will heat up during ignition, and that will obviously ignite the fuel, which then creates hot gases during combustion. And those hot, high-pressure gases exit the nozzle and produces thrust. So that's just a simple and very basic overview on how this motor works. And now we can start getting into what went wrong with this most recent test. Okay, so now I want to go into this in a zoomed-in view of the nozzle, and I want to walk through exactly what happened. So let's just watch the failure in this slow motion zoomed in view. And it's gonna fail right about now. And when it does so, let's rewind here. It can be seen for one frame where that exhaust kind of shoves into the wall. And I'll go back to the previous frame, and then you can see it moves. And what it's doing there is it's following a fracture line. There were some small cracks inside the motor, and those, of course, are going to be weak points. So the exhaust was able to find its way in there and break through. But what even made this worse is this print wasn't at 100% infill. There were pockets within the motor which weren't filled with plastic like they should be, and this led to the exhaust filling in them and overpressurization and causing even more force. It's even weaker now because it's not 100% infill. And so both of those are my fault. I should have caught those fractures, and I should have made sure it was at 100% infill. So that's basically what caused the failure in here. As you can see, it shoves it sideways afterwards, and all that force breaks off a large chunk of the motor. It kind of can be seen right there and there. There's a large gap now with half of the nozzle still attached, and it flies out to the rock, hits the rock, and knocks the other half. So that's practically what happened, and I'll go and get a bit greater depth of that whole infill and fracture issue.
Okay, so to better explain that, right here I have a 3D printed model of our NE-7 rocket motor. It's a 1-to-1 cutaway model. So right here we have our nozzle, right here we have our throat, and right here we have the inner casing. So I have my thumb placed over this specific spot for a reason. In there is a hole. And obviously that hole might seem like a problem, but the printer does that on purpose. The slicer makes a grid structure within the print so it doesn't have to spend so much time layering plastic, and that's what we call infill. Depending on the amount of infill, the higher the infill, the more solid the part is. The lower the infill, the more holes that there are. There are more gaps within it. So that's what happened. There was one of those gaps within the nozzle around in this section, and so there was fractures, like I said before, and those fractures cracked in, led a bleed hole into one of those gaps, and that allowed it to blow off a section that was fractured. And that's basically what happened. So the fuel ignited, it went well for about half a second, and then as soon as that crack got open too much from nozzle erosion, it filled up that hole, overpressurized it, and blew off that section, and then we saw the motor fly away and tear it off the load cell. Alright, so I wanted to better explain the infill patterns and the issues we had with that. So what I have here is a 3D printed nozzle of the NE-7 rocket motor. And as you can see on the cutaway model, it is pretty much perfectly just the nozzle section before it becomes throat. And if we look into this piece, there is a grid structure in here, and that's the infill pattern. And as I said before, that is done so the printer doesn't have to spend so much time filling it completely, and it doesn't have to waste so much plastic doing that as well. So it's just a good way to conserve filament. But that's not so good for a rocket motor because there's something called nozzle erosion. And what that is where the throat and the nozzle meet. The incoming high pressure gases scrape away where that throat and nozzle meet. And that obviously would decrease your thrust and efficiency over time. And with these motors being 100% plastic, it doesn't take much heat and pressure to scrape away that nozzle area. So when it has this grid structure, as soon as you break through that one layer around the nozzle right here, you go into these grid structures. And immediately as that does that, high pressure and hot gases enter these pockets, and they're not very strong at all because it's not solid plastic. So it immediately goes through here, heats up, and breaks through it. And this happened with another test. There wasn't any fractures, but it was just low infill, and that caused this issue. So here is that motor, and as you can see, there is absolutely no nozzle left. It has been completely destroyed, and that is because it filled up these pockets and blew it off. There was too much pressure for those thin walls to handle. And as you can see that structure in there. You can see where the fuel got in here and burnt away the plastic in the starter area, and it's been just completely shredded because that pressure completely blew it off. And I'll show them a video of that test in a second. So hopefully that better explains this grid structure within the nozzle and how that can be an issue. And that's why we print at 100% infill for these motors.
Okay, so here is that video I talked about, and this is that motor that I showed that also had its nozzle blown off. And again, this motor had no fractures at all, but what it did have is that low infill like I showed. And I explained all those issues, and that's exactly what happened. It exploded, and you'll see here in a sec. So yeah, as you can have seen in that video, that motor did not have a good day. Its front fell off. It's because of that low infill, and it has that internal grid structure with all the holes. So the exhaust gets stuck in those holes and explodes it off. But there were no fractures. So in this most recent test, a lot of that explosion probably was due to because of that low infill, and probably as well to those fractures. But we've had tests in the past where we've had fractures, but it's 100% infill, and it's gone completely smoothly. So it's mostly the fault of that low infill.
Okay, so now we've gone over everything that went wrong and why it went wrong. But was there any good that came out of the test? And yes, there was. Other than learning from the failure and making sure that I double checked to make sure there's no fractures and that it's 100% infill, this was a thrust test. It used a load cell, and that load cell will measure the thrust. So here I have the broken piece of the load cell. I guess the load cell's fine, it's just it got the broken mount on it. And I'm not going to go on how a load cell works, but it pushes on one side, other side's stable, and it measures thrust. And so what happened was, this was the mount it had, and as you can see, it tore itself off that mount. You might have caught that in the video, and that's why it went flying. And the amount of force needed to tear this off of that is incredible. And since the motor, so here is that failed motor, and you can see that it has that a very small amount of that pattern that caused it to fail. When it broke, all that force came from this one side, and meaning it shoved it this way. That isn't as much force pushing downwards, which is what's needed to break that off that. And obviously it broke it off that. And so when the explosion happened, it shoved it sideways. That's why we see it hit the rock, and this gray piece didn't even fly off. But the motor started to produce so much thrust it was going to tear it off anyways, and that can kind of be seen in the video. The stand's starting to slowly bend, and that means that this motor produces a very high amount of thrust. And on the load cell data, it peaked at 1 kilogram of thrust and then dropped to nothing, meaning that the load cell was overwhelmed by this, and it's only a 5 kilogram load cell as seen here. Alright, I guess this is a better spot right here. It says 5 kilograms, it has a 5 marked in there too. And it's only meant to read up to 5 kilograms of thrust. And obviously it produced a lot more than just 5 kilograms. I've pressurized or pressed 5 kilograms on here before, and it does not break it. So it had to produce a large amount of thrust, and that's obviously great news. A lot of that force was from the explosion, but also a good chunk of it was from the thrust of the motor itself, which is incredibly important because you want your motor to produce thrust, and that's the whole point of these tests. So even though it failed, the failure itself kind of pointed to the motor producing a very large amount of thrust. This means I need to get a better load cell that can hold higher amounts of force, and that's something I'll have to do later. And I'm making a separate video talking all about this load cell stand and the process of the tests, and not just this one failure. So yes, there was success in this test. Alright, so that's to wrap up this video. I hope everyone enjoyed. So motor failed because low infill and some fracture in the nozzle, but we got thrust, and that's what the whole point was. So I'll probably do another test in the next few days just to see if I can get some better results. But overall, we got thrust, and that's kind of what we were aiming for, even though it kind of failed. So I hope everyone enjoyed, and if you'd like to stay more up to date with what we're doing, I'll leave you a link down in the description with our Twitter, and we stay very up to date on that. We post nearly daily about our projects or something new we're working on. So if you'd like that, go check that out, and you can stay more up to date with what we're working on. Anyway, so this is the end of the video. I hope everyone enjoyed, and thank you for watching. See ya.